Hello everyone, welcome to my channel once again. So today we will be solving the problem find pivot index. Okay, so let's go to the description what it is saying. Given an array of integer nums, an array is given whose name is nums. We have to calculate the pivot index. Okay, now what is a pivot index? Let's have the definition of pivot index. The pivot index is the index where the sum of all the number is strictly to the left of the index is equal to the sum of all numbers strictly to the index's right. So what it means is, let's say I'm at this index 3. This index is 2, the element is 3. So what they are saying is pivot index is the left sum. Okay, that is 7 plus 1. This one, it is 8, and 6 plus 5, 11 plus 6 is 17. So since 8 is not equals to 17, this is not a pivot index. Okay, and if we go to the index number 3, this one, here the left sum is 3 plus 7, 10 plus 1, 11. Okay, this much, and right sum is 5 plus 6, 11. So in both the cases we don't have to include the index at which we are standing, right? So that is called the pivot index whose left sum is equals to right sum and excluding the current element, which is very important. Okay, now there is also some clarification regarding the edge of the array. If the index is on the left edge of the array, this means this one, that the left sum is 0. Okay, because left sum is what? The sum of all the elements is strictly to the left of the index. So since there are no elements present here left of the index, the left sum is 0. Similarly, this also applies to the right edge of the array. If we are standing at this index, last index, the right, there are no elements. Okay, so the right sum is 0. So we have to find the leftmost pivot index. There can be many pivot indexes, right? But we need to find out the leftmost pivot index. So first, as usual, let's look at the brute force solution. What is the brute force? And then we will go to the optimal solution. So in order to have the brute force solution, first let me copy this test case and explain like what I will be doing to have the brute force solution. Okay, so the array is 1, 7, 3, 6, 5, 6. So for the brute force solution, for every index, let's say we are at index I at this one. This is the ith index. Okay, we will be running a loop from 0 till less than I. Okay, and we will be calculating the sum as left sum as 8. And j, another loop, j equals to I plus 1 till less than n. I plus 1 is important. We will not include this ith element. This one, third, 3 element number 3. We will not be including it either in the left sum, no, neither in the left sum and neither in the right sum. It is 6 plus 5, 11 plus 6, 17. Okay. So since for every index you are traversing the entire array, so for one it is big O of n, for n elements it is big O of n square. So the time complexity for the brute force approach is big O of n square. Okay. So now what we will be doing is we will be not implementing the brute force solution. We'll just go to the because brute force solution will give the time limit exceeded. So now what we'll do is we'll go to the optimal solution. What is the optimal solution? Okay. So for the optimal solution, what we'll be doing is for the at the index I, we need to maintain some. We will have one variable as total sum. Okay. So total sum will equals to 1 plus 7, 8 plus 3, 11. 11 plus 6, 17, 17 plus 5, 22 plus 6, 28. This is the one variable which is the total sum as 28. And when we are starting from the iteration from the left hand side, we will have one variable as left. Okay. Left equals to 0 initially. Then we will keep on adding the elements, like after the iteration at 0th index, we will add that that element at that iteration. Okay, then left will be incremented by 1. Now see what we are doing is let's say we are at this ith index, we are at here, huh? Or this time I will choose, this time I will choose this I to be at the this one. Okay, I is this one. Now see, when we are at this place, what will be the left sum? Left sum will not be 0. Left sum will be 1 plus 7, 8 plus 3, 11. It will be 11. Okay. Now, in order to find out the right sum, what we'll do? Right sum will be total sum of the array. Okay. Total sum minus left sum. Now see, left sum are the elements strictly to the left of the ith index. These are the elements. So this will be subtracted from the total sum. Total sum will be 28 and left sum is 11. But see, in the total sum, that is the sum of the all the elements, which includes 6 also. So we need to subtract the element at that index. So total sum minus left minus nums of I. Then we will be getting the correct answer. See, so what is the total sum? I will solve this equation. It will be total sum is 28 minus 11 minus 6. So it is going to be 28 minus 17, which is going to be 8 minus 7, 1, 2 minus 1, 11. So right sum is 11, right sum is 11 and the left sum is also 11. Hence we have found out the correct answer index. Now this is the optimal solution because for one loop we are running here, which is big O of n, in order to find out the total sum. And another loop we are running here, which I have shown the dry run. Okay. So it is big O of n plus big O of n, big O of 2n. So 2 we are going to ignore because it is a constant. So overall time complexity will be big O of n only. Okay. It is going to be big O of n only. And space complexity will be big O of 1. Because we are using a constant amount of space. We are not using any array or anything. We are just using these 2-3 variables: total sum, left sum, right sum. Yeah, so this is what like I'm explaining. Now I will write down the code according to the dry run. So let's go to the optimal approach implementation. So what we have done is we'll first find out, just have a local variable n equals to nums.length. Okay, nums.length. Then int total sum equals to 0. Okay, then for int I equal to 0, I less than n, I plus plus, we will have total sum plus equals to nums of I. Okay, now we are having the total sum. Now according to the dry run, left sum will be what? 0. Then for int I equal to 0, I less than n, I plus plus, and now we will have the variable as right sum equals to total sum minus left minus nums of I. Okay, this is the right sum, total sum minus left minus nums of I. And if left equals to right, we will return the index. Like what is the index at which this, that means we have found out the leftmost pivot index. Otherwise we have to update the left sum plus equals to nums of I. That's it. Now if this condition is never executed, that means we haven't found out any pivot index in the array. So for that case, what they are saying is return the leftmost pivot index. If no such index exists, return -1. So we have to return -1 in this case. Let me submit it and check whether it, yeah, so sample test cases are working. Now let's submit it and check whether it's working or not. Yeah, so now this is working good and we have successfully submitted the problem. Now what if you are liking my videos, then please do subscribe to my channel and comment and like the videos. So that's it for the problem.